dedicated to advancing technology and promoting the country's growth across agriculture, industrial, and service sectors, while the Excellent Development Plan 2566 to 2570 BE. Transforming the university towards cultivating entrepreneurially minded graduates of economy value through modern agriculture technology and innovations that are environmentally friendly on the international stage. The faculties and academic programs at the undergraduate, master's, and doctoral levels, spanning the fields of science, agriculture, and social sciences, all adapting to align with the trend of the modern world. Faculty of Business Administration, creating and nurturing graduates into proficiency managers, financial entrepreneurs, management experts, and accountants, enabling their entries into the digital economy with excellence. Faculty of Science, fostering scientists, experimenters, and innovators from the realm of scientific knowledge towards international prominence in innovation and technology. Faculty of Fishery Technology and Aquatic Resources, curating the nation's premier repository of fishery knowledge, cultivating graduates as adept practitioners, and enhancing expertise among personnel while establishing a reputable global presence for research and innovation in the field of fisheries. Faculty of Liberal Arts, integrating science and arts from diverse perspectives to grasp human essence and cultural values, cultivating deep societal insights through creativity, communication, amidst the changing tides of our times. Faculty of Architecture and Environmental Design, converging art with science and design with the environment, sourcing knowledge that nurtures environmentally concerns, architectural designers who are considerate of the communal, societal, and environmental concerns. Faculty of Information and Communication, empowering graduates with creative skills and global media literacy, connecting theoretical knowledge to real-world practices, and seamlessly blending diverse disciplines into creative economy technologies. Faculty of Agriculture Production, elevating smart agriculture learning to the realm of intelligent agricultural innovation for the modern era, fostering entrepreneurial thinking, and employing technology in production and communication that resonates with society, culture, and the environment. Faculty of Engineering and Agri-Industry, empowering graduates as innovative practitioners in engineering and agriculture industry, elevating engineering process to creative enhance agricultural product value. School of Tourism Development, enhancing graduates with contemporary professional skills for the tourism and service industries, aiming to evaluate high-value tourism and contribute to the sustainable development of communities. Faculty of Economics, cultivating transformative analysts who synthesize knowledge in economics, finance, and treasury to comprehensively interpret personnel evaluation amidst global change. Faculty of Animal Science and Technology, fostering animal scientists with lifelong learning skills and specialized expertise in animal care technology with an emphasis on food chain dynamics and environmental ecology. Faculty of Nursing, guiding community health advancements through integrated agriculture and nutrition expertise, producing nursing graduates aligned with professional standards and the volunteering ethos. Faculty of Veterinary Medicine, producing veterinarians serving the needs of community animals, both large and small, fostering veterinary innovations for future veterinary advancement, developing knowledge frameworks for veterinary graduates to serve society, with a focus on public welfare. School of Renewable Energy, prioritizing sustainability while new alternative technologies addressing life's balance and creatively enhancing energy conversions for value across agriculture and environmental contexts. School of Administrative Studies, fostering public intelligence for change, cultivating political scientists with purpose and a solid foundation, enabling comprehensive community governments in politics, administration, and societal business realms, nationally and internationally. NJU International College, responding to the aspirations of the new generation within the ASEAN region, fostering cross-disciplinary knowledge on organic agriculture foundations, and globally enhancing agriculture output value. Major University Player Campus, the hub of agriculture, technological, and forestry knowledge aggregations in the country, focused on producing innovators and young entrepreneurs endowed with creativity and visionary thinking for an empowered community. Major University at Chumphon, the strategy for limitless spatial development potential, employing interdisciplinary synergy through the prism of tourism as a pivot, with organic agriculture as the cornerstone for healthy sustenance, encompassing plants, animals, and marine fisheries. The positive entity driving educational and research initiatives align with the university's key strategy objectives as follows. Office of Academic Administration and Development, Major University Library, Major University Offices, the Office of Agricultural Research and Extension. Major University strides into a new era of transformation, poised to adjust the country's agricultural, industrial, and service development needs in the future. Maejo, the University of Life.
Good morning, Mr. Pranav Ganesh, Indian Consulate of Chiang Mai, Associate Professor Dr. Thep Pongpanit, Chairman of Maejo University Council, distinguished guests, honored speakers, respected scholars, researchers, faculty members, students, and participants from Thailand and around the world. On behalf of the organizing committee, it's my great honor and pleasure to warmly welcome you to the 6th International Conference on Science, Technology, and Innovation 2026, held under the theme, The Science Drive Intelligent Well-Being Agriculture, here at Faculty of Science, Maejo University, Chiang Mai, Thailand. My name is Chudapak Chaichompu.
My name is Piyapat Chaichompu, and we are delighted and honored to be the MC of today's opening ceremony. Now let us tell you briefly about the conference. This conference aims to provide the international platform for researchers, academicians, and practitioners to exchange ideas, share recent developments, and discuss future directions in the fields of science, technology, and innovations. We are truly delighted to have all of you today to be part of this meaningful academic gathering.
Right. And for the outline of this morning's ceremony, we will begin with a special Thai cultural performance. And after the performance, we will be honored by a welcome address from the representative of the Indian Consulate in Chiang Mai. And the ceremony will then continue with the official opening ceremony, followed by a commemorative group photo session and the presentation of token of appreciation to our distinguished keynote speaker.
Ladies and gentlemen, thank you once again for joining us today. We sincerely hope that this conference will inspire fruitful discussions, meaningful collaborations, and innovative ideas for the future. To begin this special occasion, we are delighted to invite you to experience a remarkable cultural performance entitled แสงทองส่องเกษตรอัจฉริยศิลป์สร้างสรรค์มหัศจรรย์4ภาค Golden Rays of Intelligent Agriculture, a creative cultural spectacle from 4 regions of Thailand.
This performance beautifully reflects the spirit of intelligent well-being agriculture through the harmony of science, creativity, nature, and Thai cultural heritage. As you may notice from vibrant stage decoration featuring fruits, vegetables, and flowers, the performance symbolizes the richness of Thai agriculture and close connection between local wisdom and sustainable innovation. At the same time, the show celebrates the unique beauty of and identity of Thailand's four regions through graceful traditional dance, music, and artistic expression. Each segment represents the charm, lifestyle, and cultural treasures of different parts of the country, creating a joyful and unforgettable cultural journey for all distinguished guests from around the world.
Ladies and gentlemen, please sit back, relax, and enjoy the performance Golden Ray of Intelligent Agriculture, a creative cultural spectacle from the four regions of Thailand. Wow, this is such a fantastic cultural show, and thank you for all the beautiful dancers and the spectacle show. Ladies and gentlemen, it is our great honor to invite Mr. Pranav Ganesh from the Indian Consulate in Chiang Mai to deliver a welcome address. May I respectfully invite Mr. Pranav Ganesh to the stage, please.
It's always a pleasure to be back to Maejo University. This is my third or fourth visit over here. And I love the environments of this place. It's always a home coming to me. Anyways, Honorable Vice President of Maejo Universities, respected deans, distinguished delegates, researchers, academicians, and students from Thailand, India, Indonesia, and across the world. Ladies and gentlemen, Sawadee Khap, and a very good morning to all of you. It is a great honor and pleasure for me to be here today at the Faculty of Science, Maejo University, for the opening ceremony of the 6th International Conference on Science, Technology, and Innovation. On behalf of the Consulate of India in Chiang Mai, let me extend my warmest congratulations to the Faculty of Science for organizing this conference with such vision and scale. With 86 presenters, 86 abstracts, 96 total entries from 3 participating countries, ICSTI 2026 has clearly grown into a meaningful platform for academic exchange in the region. The theme this year, the Science Drive Intelligent Well-being Agriculture, could not be more timely as we confront challenges of food security, climate change, and sustainable development. Science and technology must lead the way. Ladies and gentlemen, India and Thailand share a civilizational bond that spans over 2 millennia. Today, we are translating that ancient friendship into modern cooperation in science, technology, innovation, and higher education. The Consulate of India in Chiang Mai places academic collaboration at the very core of our engagement with North Thailand. We have relations with almost all the big 5 Northern Thailand universities in, be it Maejo University, Chiang Mai University, Maphelong University, Naresuan University, and University of Phayao. Our focus is simple: to connect Indian and Thai institutions, facilitate joint research, and create opportunities for students and scholars on both sides. I am especially delighted to note the strong Indian presence at this conference. We have more than 30 Indian delegates attending, including keynote speakers and academic experts. Representatives from 10 Indian universities and colleges are participating physically, making India the second largest delegation after Thailand. This reflects the growing academic interest and trust between our two countries. I am also pleased to share that several memorandum of understanding are being established during this conference to strengthen future collaboration between Indian and Thai institutions. These MOU will open new pathways for joint research, faculty exchange, student mobility, and co-supervision of PhD students. I must acknowledge the close and long-standing relationship between the Consulate and Maejo University itself. Over the past several years, Maejo University has been a trusted partner of the Consulate and of Indian academic institutions. Our collaborations have spanned joint workshops, student exchanges, and research in agriculture, food technology, and environmental sciences. Maejo's focus on sustainable agriculture aligns closely with India's priorities under National Mission on Sustainable Agriculture and our national push for agro-tech innovation under Prime Minister Shri Narendra Modi. We are proud that Indian scholars have found Maejo University a welcoming home for research and that Maejo University faculty and students have engaged with Indian academic programs through various means. This two-way exchange is the foundation of true academic partnership. Distinguished guests, look at the program. The breadth of discussion ahead is impressive. 30 papers in pure and applied sciences, 15 in agriculture technologies, 12 in sustainable environment management, 11 in computer science and IT and health sciences, and 4 in artificial intelligence. This diversity shows that science today does not work in silos. It works through integration. Whether on-site or online, through oral or poster presentation, the exchange of ideas here will spark new collaborations. And that is how academic diplomacy works, quietly, but with lasting impact. To the young researchers and students present here today, you are future of innovation. Use this platform to ask bold questions, find collaborators, and think beyond borders. Some of the most impactful solutions will come from unexpected partnerships between an Indian lab and a Thai field side, between an IT researcher and an agriculture scientist. The consulate stands ready to support these connections, whether it is identifying partner institutions, facilitating joint seminars, or linking you with funding opportunities. In closing, let me once again express my best wishes for the success of this conference and my appreciation for the long-standing collaboration and active engagement with Maejo University. The consulate remains committed to deepening India-Thailand academic relations in the northern Thailand. I wish the 6th ICSTI great success, and I look forward to the collaboration, MOUs, and innovations that will emerge from these 2 days. Thank you. Khop kun makhap.
Thank you very much, Mr. Pranav Ganesh, for your warm and inspiring remarks. We truly appreciate your presence and kind support for this international conference. Your words have added great value to this meaningful occasion and further strengthen the spirit of international collaboration and friendship. Ladies and gentlemen, we shall now proceed the official opening ceremony of the 6th International Conference on Science, Technology and Innovation 2026. May I respectfully invite Associate Professor Dr. Thep Pongpanit, the Chairman of Maejo University Council, to kindly come onto the stage.
And now may I invite Associate Professor Dr. Yuvali Anprapom, Dean of the Faculty of Science, Maejo University, to present the conference report.
Thank you very much, our beautiful MC, and good morning, everyone. So, Honorable Chairperson, distinguished guests, keynote speakers, presenters, ladies and gentlemen. On behalf of Organizing Committee, it is my great honor to report on the organizations of the 6th International Conference on Science, Technology and Innovations, or the 6th ICSTI, Maejo University 2026, hosted by the Faculty of Science, Maejo University, Chiang Mai, Thailand, on May 29. This year's conference is organized under the theme, Design, Drive, Intelligent Well-being Agriculture. The main purpose of this conference is to provide an international platform for researchers, academicians, students, and practitioners to exchange knowledge, present recent research findings, build academic networks, and discuss future directions in science, technology, innovation, agriculture, health science, artificial intelligence, environmental technologies, and related fields. The conference is conducted in a hybrid format, enabling both on-site and online participation. The program includes a keynote lectures by Professor Dr. Karen Rose on green biotechnology, transforming the future on smart and sustainable agriculture, as well as parallel oral presentation sessions, poster presentations, a memorandum of understanding sessions, and award announcements to recognize outstanding academic contributions. We would like to express our sincere appreciations to Maejo University, the faculties of science, all co-organizers, advisory committees, keynote speakers, session chairs, reviewers, presenters, participants, and staff members for their valuable support and cooperation in making this international conference possible. Finally, may I respectfully invite the Honorable Chairperson, Professor Dr. Thep Pongpanit, to deliver the opening remarks, and officials declare the 6th ICSTI Maejo University 2026 open. Thank you very much.
สวัสดีครับ Good morning. The chairperson, distinguished keynote speaker, honorable guests, ladies and gentlemen. It's my great honor and pleasure to welcome you on to the 6th International Conference on Science, Technologies, Innovation, hosted by the Faculty of Science, Maejo University. The theme of this year, the conference, the Science, Dive Intelligence, Well-being, Agriculture, reflect Maejo University's strong commitment to advancing science and technologies for sustainable agriculture, intelligent systems, environmental responsibility, and quality of life. I am confident that the keynote section, oral presentation, discussion, and network activity will inspire new ideas, strategies, academic cooperation, and creative meaning opportunities for future of research and innovation. On behalf of Maejo University, I would like to express my sincere appreciation to the Faculty of Science and organization, committee, co-organizing, partner, coordinator, keynote speaker, presenter, reviewer, and all participants. Your dedication, preparation, and cooperation have made this international conference possible. With great pleasure, I now formally declare the 6th International Conference on Science, Technology, and Innovation officially open. Thank you. สวัสดีครับ
Thank you very much, Associate Professor Dr. Thep Pongpanit, for your inspiring opening remarks and valuable support for this international conference. May I respectfully invite you and Associate Professor Dr. Yuwali on the stage, please. Ladies and gentlemen, we have now arrived at one of the most exciting moments of today's ceremony, the official opening of the 6th International Conference on Science, Technology and Innovation 2026. At this moment, may I respectfully invite our distinguished VIP guests to kindly join Associate Professor Dr. Thep Pongpanit on the stage for the formal opening ceremony. Ladies and gentlemen, now, may we invite everyone in the hall to join us in the official countdown ceremony. Please get ready to count down together. Are you ready? Yes? Let us begin. 3, 2, 1. Please give a big applause to this formal opening ceremony, ladies and gentlemen. The 6th International Conference on Science, Technology and Innovation 2026 is now officially open. Well, as everybody is on the stage, we will now proceed the commemorative group photo session right now. Everybody smile. Our favorite position, right? Mini heart together, please. 1, 2, 3, smile. All right. Thank you very much. And we would like to invite our distinguished guest on second row. Please join us on the stage to take group photo together. Yes, everybody please remain on the stage, and then our Indian guests, please join us. Here in front of our beautiful stage decoration, please. Right, please. Together we can make a very memorable, unforgettable moments together, Let's wait for some more friends here. Please join us on the stage. On this side, still available. Right. This side, please. All right. Thank you. Everybody. 1, 2, 3, smile. How about like again? Everybody like. All right. 1, 2, 3. What else? Yay. How about yay? 1, 2, 3. Yay. All right. Thank you very much everybody for joining us. I would like everybody to be back to your seat, and then we will take another photo with all the audience in this hall. Everybody at the back, please be ready. We are going to take group photo together. So our photographers, please be ready on the stage. We're going to take another shot, from the stage, so we can have everybody in the frame, right? So everybody will be in the photo, Are you ready? Put lipstick on, All right, 1, 2, 3, smile, One more. How about mini heart together? Everybody. Everybody mini heart. 1, 2, 3, smile. Very nice. Lovely. Okay, thank you very much for your cooperation. Okay, give big applause to yourself. This is very memorable moment together. Okay. So, ladies and gentlemen, at this moment, we shall now proceed to the presentation of a token of appreciation to our distinguished keynote speaker. All right, so now our keynote speaker isn't here yet, okay, so our okay. Our keynote speaker, are you here? Professor Dr. Caroline Rose, okay, thank you. Please, at the stage, okay, we are now presenting you token of appreciation from Associate Professor Dr. Thep Pongpanit, our chairman of Maejo University Council. All right, thank you very much. Okay, and once again, thank you very much, Professor Dr. Caroline Rose, for graciously joining us and share your knowledge today. And could you please remain on the stage, Professor Dr. Caroline Rose, once again. Okay, are you ready for your? Okay, very good. Okay, so right now, we are truly honored to welcome Professor Dr. Caroline Rose from St. Joseph's College of Art and Science for Women, also Tamil Nadu, India. So before her presentation starts, we have to prepare something on the stage, and also for the keynote speaker to prepare something as well. So let's take some break together, okay? So you can enjoy refreshment and feel free to relax, okay? And maybe in 10 minutes we'll be back here to enjoy our keynote speaker session. All right, we'll be back in 10 minutes. Thank you. May I have your attention, please? Our Indian friend here maybe left a mobile phone with someone, and he asked that person to take a photo. I'm not sure if he left. Okay, thank you so much.
Recording in progress.
I walked through flames to feel alive. With every step I took, I thrived. The heat was wild, but it couldn't consume the ashes beneath sang a silent tune. Through the fire, I found my name.
Right, ladies and gentlemen, we are truly honored to welcome Professor Dr. Caroline Rose from St. Joseph College of Art and Science for Women, Honshu, Tamil Nadu, India. And the professor will deliver a keynote lecture on the topic Green Biotechnology, Transforming the Future of Smart and Sustainable Agriculture. Ladies and gentlemen, please join me in giving a warm welcome to Professor Dr. Caroline Rose. The stage is yours.
Thank you. Good morning to all the dignitaries on the dais and off the dais. Good morning to all the faculty members, researchers, students, ladies and gentlemen. I am Dr. Caroline Rose from St. Joseph's College of Arts and Science for Women, Hosur, India. It's a great honor and privilege to deliver this keynote address on the 6th International Conference on Science and Technology and Innovation, Maejo University, 2026 on the topic, Green Biotechnology, Transforming the Future of Smart and Sustainable Agriculture. So before going into green biotechnology, I'll tell something how the agriculture has been transformed from the previous years. So biotechnology is not just transforming agriculture, it's transforming the future of humanity. So why this smart and sustainable green biotechnology? Let us have a glance of traditional agriculture and green revolution before going into smart, that is green biotechnology. So just I'm not going to explain. We know what is traditional agriculture. Traditional agriculture, agriculture was not merely an occupation. It's a foundation of human civilization. Every meal we eat, every textile we wear directly or indirectly, it depends on agriculture. For centuries, farmers, they work closely with nature using traditional farming methods based on rainfall, organic manure, and manual labor. So these traditional methods alone are no longer sufficient to meet the demand, and so green revolution came into implementation. So in green revolution, they used chemical fertilizers, pesticides, herbicides, and new irrigation systems and modernized mechanism, and they found high yielding variety by genetic breeding technologies. But again, these persons were these are the two persons, that is Norman Borlaug and M.S. Swaminathan. They introduced high yielding variety by breeding. So this green revolution, even though it solved the problem temporarily, there was so many issues arise due to this the green revolution. That is, many pesticides and herbicides were used to the soil, and hence what happened is it started to deplete the natural fauna and flora of the soil, and so there was we had to search a new technology. There came this green biotechnology. Now we'll go into the topic, green biotechnology. So I think all of you are aware of biotechnology. Biotechnology means it is manipulating the gene for the welfare of the humanity. So green biotechnology includes this genetic engineering and plant tissue culture, molecular markers, CRISPR, CRISPR gene editing, and we use biofertilizers and biopesticides and hydroponic. Currently, hydroponics and vertical farming is in existence. So as I am a biotechnologist, I'll go deep into tissue culture. What is tissue culture and what is genetic engineering? That's my topic. How this tissue culture and genetic engineering is going to create a future world, sustainable agriculture. So what is meant by tissue culture? Actually, from a single cell, you can get a whole plantlet. That is tissue culture. I think all of you are aware of this tissue culture. May I know how many of you are aware of this tissue culture? Can you please raise your hands? Tissue culture. Okay. So in plants, the plant cells are totipotent in nature. Totipotent means that's from a single cell, we can get the whole plantlet. That is tissue, totipotency. So plant cell alone is totipotent in nature. In human, the embryo cells are totipotent in nature. But in plant cell, all the cells are totipotent in nature. They have the capability of developing into an whole plant. That is, the cell multiplies, it undergoes organogenesis, it undergoes differentiation, de-differentiation, and finally we can get the plantlet. That is what it is, we tell it as tissue culture. And there are many types of tissue culture. You can take any part of the plant for tissue culture. We can take a stem, you can take a root, you can take a leaf, you can take a bud, you can take a scale. All the parts of the plants are totipotent in nature. Are you able to follow me? If any clarifications, if you have any doubts, you can ask. So plant tissue culture, once again I repeat, plant cells are totipotent in nature. Totipotency means ability of the cell to transform into a whole plant. That is totipotency. In human cell or in animal cell, only the fertilized embryo has the capability of developing this totipotency nature, and that's why from an embryo, fertilized embryo, we'll get a whole organism. But here, in case of plant cell, from a single cell, you can get the whole plantlet. So that's what this is. So in this culture, there are many types of culture. The main thing is, the main one is called the scalous culture. So the scalous culture, we can use the scalous culture. You take a single part of a plant, a stem or a root or a shoot or a leaf, you take it and place it in a culture media. So you should know what is culture media now. The plants, when it is grown in the soil, it takes nutrient from the soil and from the atmosphere. But while culturing in a media, in vitro condition, we are going to grow the plant in a test tube or in a closed container. So we have to supply all the nutrient essential for the growth of the plant. That we tell it as culture media. So the culture media is made up of all the nutrients, micro and macronutrient. Micronutrients and macronutrients includes calcium, sodium, potassium, phosphorus, magnesium, iron, zinc, boron. All the nutrients required for the growth of the plant should be supplied in the media. And along with that, we have to add the growth hormones. Even like humans, we have hormones, plants, they have hormones, which we tell it as growth regulators. That is, growth activating hormones are there, growth inhibiting hormones are there. So growth activating hormones means auxin, gibberellin, cytokinin, and growth inhibiting hormone, ethylene and abscisic acids are there. So here, we should add the hormones also to the culture media, that is to the Petri plate or to the test tube. So now we have to keep the part of the plant which we are going to culture. The part of the plant may be a shoot, root or anything. Any part of the plant can be taken, and that part is called as explant, E-X-P-L-A-N-T, explant. That explant has to be sterilized first. Sterilizing means we have to destroy all the microorganism present on the surface of the plant. So we have to use calcium or sodium hypochlorite, and you have to surface sterilize it, and then we have to inoculate into the media. So once the plantlet is inoculated into the media, it goes and develop into a callus, and that callus is a mass of undifferentiated group of parenchyma cells. So these cells, they have the capability of multiplying again and again as they are again totipotent. Now these cells can be subcultured again and again, and from this we can go for somatic embryo. Somatic means, I think all of you are aware, somatic means body cells. So these plant cells, normal part cells, they have the capability of developing into an embryo. Only this plant cell have the nature. In animal cell or human cell, we don't have this capability. But in plant cell, they have the capability of converting the somatic cell in embryo. So how to convert the somatic cell in embryo? So now this callus, when we add certain media like auxin and gibberellin, they get a single cell, they get transformed into an embryo. Embryo means that cell will get differentiated from the other cell by having a prominent nucleus and a large cytoplasm. And these cells starts to divide, and then it gets converted into a torpedo shape and finally into an embryo. This embryo can be encapsulated in sodium alginate, and we can get synthetic seeds or artificial seeds. So if you go for this embryo culture, we can get a synthetic seed or artificial seed. So for the plant which we are not having a seed, we can generate seed by this synthetic seed technology. We know that all the plants will not having the seed, but the plants which is not having the seed also, we can get a seed by this somatic embryogenesis. And protoplast culture is a very important technique which is used for hybridization. So nowadays we are getting hybrid plants. So by culturing the protoplast, we can get fused plant, that is hybrid plant. You can fuse two varieties of crop. That means first we have to isolate protoplasm. Protoplasm is a cell without cell wall. A cell without, from a cell, if you remove the cell wall, that is called as protoplasm. Now this protoplasm of two varieties, for example, I say variety A and plant B. Plant A will be having disease resistance, and plant B will not be having the disease resistance, but it will be high yielding. So you can cross both the protoplasm. You can fuse both the protoplasm. That is protoplasm of the high yielding variety and protoplasm of the disease resistant plant. So when you fuse these two together, you can get a hybrid plant with high yielding capability as well as disease resistance. So that is the importance of this protoplast culture. So we can go for callus culture, meristem culture, cell suspension culture, embryo culture, protoplast culture, organ culture, or micropropagation. So any of these methods can be used for getting the plantlets. Now this next is genetic engineering. So the genetic engineering plays a very important role in gene manipulation. So we can manipulate the gene of a plant cell, but we can't manipulate the gene of any animal or any living organism, that is bacteria or anything, because that will be hazardous to the environment. If you manipulate the gene of a bacteria, we should handle the bacteria carefully. If it is released into the environment, it will create so many problems. So, but we can manipulate the gene of the plant easily by using certain microorganisms. So so these are all the methods of genetic engineering. We can transfer the gene by either by using a chemical method, or by using a physical method, or by using biological methods. So biological methods are very good methods. That is, we use a microorganism called Agrobacterium tumefaciens. So Agrobacterium tumefaciens, it has a tDNA which have the capability of attaching the attached gene to the host plant. If you stitch a gene with that Agrobacterium tumefaciens tDNA, that will transfer the gene into the host cell. So you can use agrobacterium mediated gene transfer, you can use particle bombardment method, which is called as biolistic method, you can use electroporation method, and even we can use the other methods which we tell it as chemical methods and physical methods. So manipulating the gene is very easy. So with this we have got herbicide tolerant plant, pesticide tolerant plant. In India we have got BT toxin, BT cotton. So how is this BT cotton obtained means there is a bacteria called Bacillus thuringiensis, that's called BT. So that organism is having a protein called cry protein, CRY protein, cry protein. Now the scientists, they have isolated the cry protein gene, the gene coding for this cry protein, and they have stitched it into the cotton plant by using the organism Agrobacterium tumefaciens. So that is, we have to take the gene of this cry protein, then we have to stitch with the tDNA, and we have to introduce into the Agrobacterium tumefaciens, and then the Agrobacterium tumefaciens is made to inject the cotton plant. And this cotton plant, then you have to select the plant which has got this gene, and then we have to culture it. So now you can see, I'll show you the image. You see, this is the image. So the plant leaf will be having the BT toxin, the toxin which code for the cry protein, and when the insects come and eat it, the gut will be lining with the protein. Because that is a toxin, this protein will go and line the gut of the organism, and when it feeds on the leaf, the insect will die. And so thus we can protect the crop from this method. Then herbicide tolerant plants are also made, this golden rice, this pesticide resistant crop, and increased yield. These are all the crop which is found successful crops in India. So how to find? We have to find out whether our desired gene is inside the plant or not. We have introduced our desired gene into the plant, but we don't know how the plant is got the gene or not. We have to identify. So there are certain molecular marker techniques. By using this marker, we use marker to highlight something. So if these markers are present in the plant, then we can tell our desired gene is there. So these are the molecular markers which are used: RAPD, RFLP, ALP, SSR, and SNP. These molecular techniques will identify the presence of our desired gene in the plant. I'm not going to explain that. This is a lengthy procedure. Each will take time. So this, we can, by the use of these markers, we can find out whether the inserted gene is inside the plant or not. This is a very important method which is currently used in biotechnology. So this CRISPR-Cas gene biotechnology. So this technology, it is replacing the diseased gene. Imagine you have got a plant which is giving high yield, but this is having a disease susceptible gene. The plant is getting easily infected with some disease. So there are certain genes which has to be removed, or we have to replace the defective gene with the corrected gene. So this CRISPR-Cas is a protein. So there is a guide DNA in that. There will be a protein called Cas9 protein, and this will go and bind to the target location. And this Cas9 is a protein which has the capability of cutting the gene and removing the defective gene. So this Cas9, it will go and cut the diseased gene precisely with the help of the guide DNA. This guide RNA will guide the scissors, that is the Cas9 protein, to the precise location. So once it goes to the precise location, it will cut the diseased gene, and then that diseased gene will be removed and it will be replaced by the good gene, that is the non-defective gene. So this is a very important currently going technique. That's why I have given explanation to this. The component of the system is guide RNA, a Cas protein. And the mechanism I have explained, but identifying the target gene, binding of the RNA to the protein, then DNA cleavage, and it repairs the DNA and it will modify the gene. So this application, by using this, we can get disease resistant plant, drought tolerant plant, we can get saline resistant plant, we can get improved nutritional quality plant, high yielding crop. And we can reduce the usage of pesticides, we can improve the climate resilience plant, then enhance food security, support sustainable farming. So this, and we can get vitamin enriching crop. Then mushrooms, as we know, if you cut and keep, it will become brown. So that non-browning mushrooms can be made. Then drought tolerant maize and blast resistant plants can be obtained. The next is use of nanotechnology, nanobiotechnology. So nanobiotechnology is also a current technique which is used for agriculture. It is used in all the field, but it is used in agriculture. You can see nanopesticides. Pesticides, if we apply, overall it will pollute the soil and the environment. But if you use the nanopesticides, it will be limited. It will reduce the pollution of the soil and pollution of the land. So nanopesticides, nanofungicides, nanoherbicides, genetic modifications can be made. Even seed germination can be done by using this nanotechnology. Pesticide resistant residue, if any pesticide residue is there, you can detect it by using nanosensors. And pathogen detection also can be done by using this nanosensors. Then nanofertilizers and nanoinsecticides are also available. So I told the techniques. So what is meant by nanofertilizer? Just I'll explain with the help of pesticide fertilizers alone. So nutrients are reduced to nano size and they are encapsulated in some carriers. So the carrier, for example, we have prepared nano urea, nano zinc, nano iron, nano copper, nano NPK and nano silica. That is, this will be the supply of the nutrients will be limited only to the location, not to the soil. If, for example, if you use a normal fertilizer, it will be there in the soil. When rain falls, it will carry it to the water. So overall food chain will be polluted by the particular fertilizer, chemical fertilizer, and it will destroy the natural fauna and flora of the soil. Whereas, if you use this nano zinc or the nano fertilizers, it will only provide the nutrient in limited quantity to the plant alone. And that is slow release of nutrient will be happening. The nutrients will be released as per the requirement of the plant. So slow release of the nutrients will be happening by this method. So it will, controlled release will happen, then easy penetration is possible, enhanced uptake is possible, transport within the plant and improve the growth and yield of the crop. So nanotechnology I have given. So that's all about the use of green biotechnology in agriculture. So biofertilizers have this I think this I'll skip. Now the novel method which is used in highly populated countries is hydroponics and vertical farming. Countries like India, it is highly populated, and highly populated countries, even China also, they are following this hydroponics and vertical farming. Hydroponics means growing the plant without soil, growing particularly in Kerala and many other states of India also, they are following this hydroponic method. In water, they'll give all the nutrients. In closed pipelines, you can grow the crops. So hydroponics, by the help of hydroponics, we can grow green leafy vegetable, herbs, strawberries, tomato, cucumber, etc. These are all in existence. They are creating crop like we are getting these products in India. And even this, what is vertical farming, same hydroponic and aeroponics. By using water or by air, they are growing the plants. And this can be done in vertical method. Here we can see in pipelines we'll cultivate. There the same procedure it is done in stacked procedure. So we can get area can be in a small area we can get large quantity of the vegetable. So this usually many in Bangalore they are doing this vertical farming as well as in this hydroponics they are doing in Bangalore to near Bangalore a place Attipalli they are farming using this farmers there they are growing this. So that's all about the role of biotechnology in green biotechnology. Next is, I have told few points regarding this smart agriculture. I think here you are aware of the smart agriculture. So by using IoTs, we can find out the soil moisture, temperature, and we can use sensors to identify the soil nature, and based upon the requirement, it will be automated. Everything is automated in this. The agriculture can be done by using this precise farming with the help of smart agriculture. IoT sensors are used. So the next few, so key messages. Green biotechnology can enhance productivity, it can protect the environment, it can support sustainable agriculture, and it can ensure food security and future generation. I say that, once again I repeat, biotechnology is not transforming agriculture, it is transforming the future of humanity. Thank you. More slides regarding the next thing also, but I'll stop with this. Any clarification? If you have any doubts in this, you can ask. Any queries? Thank you. Thank you for your patience. So, I thank the organizers of this conference, and I also thank my secretary, Sister Dr. Donna Grace J. for giving this opportunity. I thank the team from India, Dr. Raghavan sir, Dr. Jayaprakash, Dr. Kavita, Dr. Jalisha, Dr. Mahalakshmi for encouraging me. Once again, I thank our college management and secretary sister for continuous motivating to attend and organize such programs. I thank the dean, name? Yuvali ma'am and Ramesh Kumar sir, Ramesh Prabhu sir, for your continuous support. I thank the Vice President and college management for giving me an opportunity. Thank you all.
I'm waiting for the query, ma'am. Sorry for disturbing you.
No issues, sir.
Okay, since you are talking about biotechnology, and currently every university in the world, they are trying to find out funding agencies and also sharing the seed, cultures, and also lab equipments. So what you proposed for next 5 years, if possible, if there are universities between Thailand, India, Taiwan, Brazil, Egypt, any countries, if they wanted to share equipments and also seed, what is the possibility you have in your mind?
Seed in the sense they'll provide the seed. Okay, seed in the sense, seed, you are telling about the plant seed. So if they provide us the seed, what will be? We'll convert the seed. If we'll identify what's the nature of the seed, whether it is a disease resistant, or if not, we'll try to manipulate the gene, and we'll get a plantlet which can give us sustainable farming.
Thank you, ma'am.
Thank you.
Does anyone have any question for Professor Dr. Caroline Rose? Okay, no, thank you. Please join me once again in giving her a big round of applause to Professor Dr. Caroline Rose. This is such a inspiring and insightful presentation, and we truly appreciate your meaningful contribution to this conference. Ladies and gentlemen, we will now have a parallel session. But before we start the parallel session, there is a coupon for the coffee break and lunch behind your badge. Okay, you can give this to our staff, right?
Right. For lunch, you can take it from the registration point, and also for the afternoon break, you can take it at our coffee truck. There will be drink and cake provided for you in the afternoon.
Right. And after the break, there will be parallel sessions as informed in the schedule. And if you are not sure where the room is, please kindly ask our staff. We are more than happy to assist you.
Right, ladies and gentlemen, that is now the end of the opening ceremony and keynote session. Thank you very much for joining us today. Have a good afternoon. Thank you very much.
Thank you.
สวัสดีค่ะ
สวัสดีค่ะ